Gradients of tangents. This is the start really of the calculus, and we're doing this from first principles. First of all, we'll work out the gradient of the secant, and I've written up here x and function x plus h, and this will be function x plus h. So this stands for a general function, and later on we'll look at this particular one, how we apply it to this one. Okay, first of all, we'll look at the gradient of the secant. So the secant, as you know, is just the difference in the y values. So it'll be function x plus h minus function x all over x plus h minus x. And that gives me function x plus h minus function x all over h. And that's the gradient of the secant. Now as this point here moves down and the h here gets smaller and smaller and smaller till it lands on there, when h approaches 0, then this will approach a straight line which is tangential to this particular point, or the tangent. So we're after the gradient of this tangent. And to do that, we just say the limit as h goes towards 0 of function x plus h minus function x all over h is the gradient of the secant, of the tangent, and that is written as f dash x. Right, so how do we apply this to y equals x squared? Well, we'll do the same sort of thing. We'll have here, that's going to be x, that'll be function x, this will be x plus h, function x plus h. So the f dash x is equal to the limit as h goes towards 0 of function x plus h minus function x all over h. So all we need to do now we know what our function is replace x plus h in the x, and we'll have x plus h all squared minus the function x squared all over h. That's simple. And now we're going to get, removing those brackets, we'll get x squared plus 2xh plus h squared minus x squared all over h. This goes out with this, and now we'll have the h, I'll write this out again, the limit as h goes towards 0, that's going to be 2xh plus h squared. We'll pop the h underneath each one, and of course you can see here that that will become, they go out, and that goes out with that. So as h goes towards 0, this will go out, and we're just left with 2x. Gradients of tangents. This is a different way of working out the gradient of a tangent from first principles. First of all, work out the gradient of the secant. So the secant is equal to the difference in the y values, that's function x minus function 1 over, it's going to be x minus 1. So a bit different, isn't it? So the gradient of the tangent will be the limit as x goes towards 1, right? Because this is going down towards 1 of function x minus function 1 all over x minus 1. Now the simple part, let's pop these things in. Function x is this, x squared plus 2. Function 1 plus 2 is 3, all over x minus 1. And that gives me x squared minus 1 over x minus 1. Now here's where that limit theory pops in. So now we go write that as the limit, there's 1 there, as x goes towards 1. This becomes x plus 1 factorising, x minus 1 over x minus 1. And because these x minus 1s go out, and then you substitute 1 in for here, and we get the value of 2. Okay, moving on to this one. Same sort of thing. We're going to work out the f dash x, or the gradient function, is the limit as x goes towards 1 again, going towards 1 of, this will be function x minus function 1 all over x minus 1, which is a limit as x goes towards 1. Function 1 this time is x cubed. That's just going to be 1 over x minus 1. Another bit of factorising to do. Can you remember how to factorise x cubed minus 1? That's x minus 1, x squared plus x plus 1, all over x minus 1. These dudes go out, and you put the 1 in there. 1 plus 1 plus 1 is simply 3. That's it.